In this video, we are going back to one of the problems from the test. We have Ali and Bea, and they are each one on a side of a fence of height h. And we have from Ali's standing point the angle of elevation to the top of the wall, that's 35, and from Bea's the angle of elevation is 55. We have to sketch a situation, and given that Ali is 5 meters further from the fence than Bea, we have to find the height of the fence. Let's begin by sketching the situation. So we have our fence with height h, and then we have to draw the angle of elevation. Let's say that this one is 35 and this one is 55. On each side of the fence we have one of our characters, Ali and Bea. And the other piece of information that we have is that Ali is 5 meters further from the fence than Bea, so if we call the distance from Bea to the fence x, we're going to call the distance from Ali to the fence x plus 5 meters. This is how we are going to work. I'm going to present different ways of solving this problem using different tools. I'm not going to finish any of those ways of solving those problems. I'm going to set up the problem. I'm going to try to explain enough to make sure that you can continue on your own. So you're going to be finishing this problem many times using different tools. I want to mention that some of the tools actually were ideas that you had when solving the problem during the test, and I had not thought about them before writing the question. So it was nice to see that you use your problem solving skills, even if you didn't get to the final answer. But now I want everybody to see all those different ideas, and I want everybody to finish the problem in all those different ways. So the first possible solution we are going to look at here. This is actually the most straightforward, I believe. Just we have to deal with a little bit of algebra, and this was the one that I hinted when you have a problem very similar to this one on assignment. So many of you actually did solve a problem very similar to this in the assignment with my help. And that's what we're going to do here again. So I'm going to focus on each of the triangles, and I'm going to write two equations and two unknowns. So for this triangle where we have 35 degrees, h as the leg opposite to it, and x plus 5 as the leg adjacent to it, we can write that tangent of 35 degrees is the same as h over x plus 5. At the same time, if we focus on the other triangle, the one with the angle of 55 degrees, again, the leg opposite to it is h, and this time the leg adjacent to it is x. So we can write that the tangent of 55 degrees is equal to h over x. So actually here we have a linear system with two unknowns and two equations. Our unknowns are h and x. And we are going to isolate h on each of the equations because that's the easy thing to do. So we are going to say that h is the same as tangent of 35 times x plus 5. And also h is the same as tangent of 55 multiplied by x. So by substitution, we can say that tangent of 35 degrees times x plus 5 is the same as tangent of 55 degrees times x. Now we are trying to solve for x. You may be tempted to find in the calculator what are the values of tangent of 35 and tangent of 55, but I do not want you to do that because then you will be using approximations and that will be affecting your final result. Instead, just going to remember that this tangent of 35 and this tangent of 55, they're just numbers. I don't know what they are, but they are numbers. So I'm going to write on one side all the terms that have x. We have the term tangent of 35 degrees multiplied by x. This note here I obtained it by expanding against this bracket, so I'm multiplying tangent of 35 times x and tangent of 35 times 5. So that's where the tangent of 35 times x comes, and then I'm going to have minus tangent of 55 times x. That's the term that we have on the right hand side. And all of this has to be equal to minus 5 times tangent of 35. This is coming from the second term of the expansion, and on the other side we have a negative sign. So now we have tangent of 35 times x minus tangent of 55 times x. I'm going to take x as common factor, so I'm going to have a bracket that has tangent of 35 minus tangent of 55. All of this is multiplying x, and this has to be the same as minus 5 times tangent of 35 degrees. What were we trying to do? Well, we were trying to find the value of x. We are very close to being able to isolate x. So I suggest that at this point you stop the video and you try to find what x would be and then what h would be to finish the problem. But I think from now on you should be able to do it alone. If you have done your work, you can now check it against mine. I found here the value of h in terms of tangent of 55 and tangent of 35. And now this is the final result we want to find. So it's at this point and not earlier that you want to use your calculator to find an approximate value for h. And I'll let you do it yourself. Let's see a second possible solution. Notice that the two angles we are dealing with, right over here, we have an angle of 35 degrees and we have an angle of 55 degrees. If we sum, actually, that gives us 90 degrees. That means that in the left right angle triangle that we have in Alice's right angle triangle, the angle that we are missing over here on the top is actually 55 degrees. And on the right side, on Bea's triangle, the angle we are missing on the top is actually 35 degrees. And then we are forming over here a right angle. So we have a right angle triangle with two right angle triangles inside. And this is the main idea. What we are going to do is we are going to find the area of that triangle in two different ways. So we're going to say that the area of the triangle, we will find it as a half times h, that's the height of the fence, times the base, and the base is x plus 5 plus x. So it's h times 2x plus 5 all divided by 2. This is one way of finding the area of the triangle. But since it's a right angle triangle, we can also find the area as a half times the length of one of the legs. Let me call the leg on Alice's side A and the leg on Bea's side B. So times A times B. Okay, at this point it looks like we are introducing two new unknowns, and that's too much for the problem. But let me write A and B in different ways using trigonometry on the small right angle triangles. For instance, on Alice's side, we could say that the cosine of 35 degrees is equal to the side adjacent to 35, so x plus 5 divided by the hypotenuse, which is A. So that means that we can write our side A as x plus 5 divided by the cosine of 35 degrees. So we do not need to introduce a new unknown a, because we can write it in terms of x and the cosine of 35. Similarly, the cosine of 55 degrees can be written as x, that's the side adjacent to 55 in the small triangle, divided the small triangle on the right side, divided by b, which is the hypotenuse. So we can write b as x divided the cosine of 55 degrees. So with this information, going back to the second way of finding the area of the triangle, we can say that it's a half times x over cosine of 55 degrees times x plus 5 over cosine of 35 degrees. Okay, what have we done? We have found the area of the triangle in two different ways, but the area has to be the same, so we can say that those two values are the same. So we are saying that h times 2x plus 5 over 2 is the same as x times x plus 5 over 2 multiplied by the cosine of 55 degrees multiplied by the cosine of 35 degrees. And of course we can cancel over here the factors of 2 dividing on both sides. We have one equation and we have two unknowns, so we need one more trick. We need to also write h in some different way that involves x and possibly some trigonometric ratio of one of our angles, but nothing else. So we could do that. I think the easiest way would be to look one more time at the small triangle and notice, for instance, that we can write that the tangent of 55 degrees is equal to h, the leg opposite to it, divided x, the leg adjacent to it. So instead of h, we can write x times tangent of 55 degrees. So going back to this h over here, we are going to substitute by x times tangent of 55 degrees times 2x plus 5, and then that has to be the same as x times x plus 5 over cosine of 55 degrees times cosine of 35 degrees. And at this point, we need to isolate x. I think you should pause the video and you should try to do it yourself. There's a little bit of algebra involved. Just remember that the values of the cosine of 35 and 55 and the tangent of 55 are just numbers, and we treat them as such, but we do not find approximations because we don't want to affect our final result. Okay, so you can see how I managed the algebra over here to get to the result of finding first x and then h. You may notice that over here I had this long expression with tangent 55 times cosine 55 times cosine 35. I just call all of that k because it's just a number, and that helped me to be able to deal with the algebra more easily. And then at the end, when you're finding the value of h and you are entering the values in the calculator, you're going to have to write all of this instead of writing k. So we have here the second way of solving this problem, this time noticing that the whole triangle is a big right angle triangle and finding the area of that triangle in two different ways.